right, and then next up we have Marc-Andre Lemburg talking Python, solving complexity at scale. Marc-Andre Lemburg is co-founder of Python Düsseldorf, CEO of eGenix in Germany. He's a Python core developer. He designed and implemented the Unicode support in Python, Unicode, y'all, languages. And he is author of the MX extensions for Python, including MX Tools, MX Daytime, MX ODBC, and many more. And I should also say he has helped organize this wonderful event, so an extra warm round of applause, please, for Marc-Andre Lemburg.
Okay, so welcome to my talk. This is my time to do some work at this conference, so not only introducing other people. I'm going to give you a quick introduction into what event-driven architectures are, and then also talk a bit about how you can use Python in this. So a bit about myself. I'm Marc Lemburg. I've already been introduced by Uchi, so won't go too much into detail here. I've done lots of stuff in the Python community for many, many years. I've been using Python for a very long time, as you can see. I have a consultancy, eGenix. I'm working as a senior solution architect in there. Also provide coaching services and consulting. So if you have a need in that area, feel free to talk to me. So what are we going to do in this talk today? I am going to give you a quick introduction into the basics of event-driven architectures, and then I'm going to talk about a bit of tooling that you can use for that. And after that, I'm going to talk about, obviously, how you can use Python with this. So let's get started. Sorry, skip that one. So let's say you have a startup, right? And you want to, implement an architecture to implement your solution and run with that. Now, typically when you start into something new, you don't know where you're going to end up. So if you want to really have a good architecture that scales up easily and is prepared for all kinds of different issues that you might run into, like getting lots and lots of users, getting lots and lots of requests, that kind of thing, then you have to think carefully about choosing the right architecture for whatever you want to do. And so the event-driven architecture is going to provide you with something that is very, very scalable, that's very easy to adapt, that's very easy to also use for making changes to your architecture later on. So you're not digging yourself into some rabbit hole. So some things that you have to be careful with. So you have to be sure that you're scalable horizontally and vertically. So you get lots of requests, but you might also have the situation that you have to integrate with lots of different systems. You need to be prepared for the enterprise if you want to enter that kind of space. So you're not providing services to the end users, but you're providing services to companies, and you maybe want to integrate with the services that companies already have, then that's very important. There are a couple of things that you have to be aware of in that space, which one of the most important ones is governance, so that needs to be built in right from the start. Another very important aspect is observability. I'll get to that a bit later on. So let's have a look at what typically is being used nowadays for writing applications in that space. So say you have a website, maybe it has an API, you want to start providing that to people. The two architectures that are used for these things are REST, and the second one is GraphQL. REST you probably already know. How many of you know REST? Most of you, excellent. So won't go much into detail there. The problem with REST is that it makes it very, very difficult if you want to change the data that you have in your backend. So every time you have new data in your backend, you need to create new APIs for that in order to manipulate it or to record new things in your database. Now, there is a solution for this, and Patrick already presented that, which is called GraphQL. So essentially what you do there is you tap into your database more directly, and the front end can actually tell the back end what kind of data is being used or needed for that particular web request that you're sending. So you only get the data that you actually need. You don't get, like with REST, for example, you very often get too much data. and then you just throw it away on the client side. So there's unneeded bandwidth that you're using, unneeded CPU compute on the server side. So GraphQL makes this a lot easier. But both of these architectures are hard to scale. So this is where event-driven architectures come in, EDA. Event-driven architectures are actually something that's rather old, so it's not a new architecture. The first time I heard of this architecture was around the early 2000s when something else was being hyped. It was called SOA at the time, service-oriented architecture. IBM and Oracle were very big in that space. What I'm going to talk about, the event-driven part of this, was actually part of SOA. Another part was the REST architecture. And as you all know, REST basically took over the world. Everyone started to use REST. The event-driven part started to be forgotten a bit in the enterprise. And so these days, a lot of talk is going on about reviving EDA, reviving the event-driven architecture to make things more scalable. You actually all have this architecture running on your notebooks already, because if you're using a UI on your notebook, then the UI is actually using event-driven architecture. So every time you move the mouse around, you click somewhere, events get generated. And then you have applications that listen to these events. And the nice thing is that the mouse doesn't have to know about your application. It just has to know that it's being clicked and then sends the event. And so the application can then do something when you click a mouse button. And likewise, the application itself doesn't know what kind of mouse you're using. So you basically have a separation there, and that's much intended. So this is the main concept behind event-driven architecture. It's mostly about how you communicate between different components that you implement in your application. Everything is being done using messages, and messages in EDA are typically then called events. The nice thing is that everything is fully asynchronous, so you send an event, you don't wait for the answer, someone's going to deal with it, and then you're going to get a message back, and then you can process the result of that particular event. There are two very important parts in EDAs. One is called the producer. Producer generates events. So in my example, that was the mouse. And then you have a consumer. That would be the application that then consumes these events. And in between, you have a broker. And that's the central part in the event-driven architecture. So the broker takes care of making sure that the communication between producer and consumer actually works. And this is also the nice thing about the infrastructure, because you can leave all the hard work and all the difficult to implement stuff to the brokers. So you can focus entirely on just implementing consumer and producer parts. Now let's have a closer look at events, or the event messages. Typically, events are things like something happened, or a state change, or you want to initiate some kind of command. Those are events. And what you do is you put these events into messages, and then you send them around. Now, of course, you don't want to send around huge messages. So let's say you're working on a document. You don't want to send the document around with every single message that you're sending, right? So you have to make sure that these events, the messages for the events are just very, very small messages. And when you want to reference larger documents, for example, or larger data that you have, then you just send a pointer or an ID, or maybe even provide information about where to get that content, so that the consumer of that message can then get the data as they need it. And it's similar to GraphQL. You also avoid sending around too much data all the time, so you just have the consumer get whatever data they actually need. Typical formats to use for this are the ones I show here. So Apache Avro is a very standard one because it's being used by Kafka. How many of you know what Kafka is? Quite a few, that's excellent. So Kafka is one of the major brokers that are being used for these things. But there are other types of payload encoding formats as well, like protobuf or Apache Thrift or even message pack or JSON. What's important in all of these is that they are typed. And Specifically for JSON, you don't have types directly in JSON, so you need to make sure that you always use JSON schemas for this, so that the consumers can check that the messages arriving are actually valid messages in your format, right? Another thing to be concerned about is security, because if you have lots of different components running in your system, you want to make sure that there are no components in that system that are doing nasty things to your architecture. So you need to make sure that the messages being received and processed are valid messages in the sense that you trust them. And a very easy way to do that is to just sign messages. And if you combine those two and you add compression, you keep everything very small, and at the same time, everything is very secure. So that's a good way to do things. Now, how do you distribute those messages? There are essentially two ways to do this. The first one is on this slide, is publish, subscribe, pub/sub. How many of you know that one? Also lots of people, that's good. So publish, subscribe essentially means that the producer says, okay, I'm going to publish these messages, and the messages, in order to keep them organized, are then grouped in topics. Sometimes you have so many topics that you need to add another level of management on top, and you have categories for these. So that's all doable, and brokers typically take care of that part for you. So you just say, okay, this is my topic. I'm going to publish that message under that topic, and then consumers can go in and say, okay, whenever a message of this topic arrives at the broker, I want to be notified. I want to receive a notification of that message, and then can get the message and process it. There's a downside to this kind of approach, which is the major downside, which is that messages cannot be resent to new subscribers. So let's say a new component gets added to the system dynamically. Let's say you're scaling up your backend. Then the components that then register themselves as consumers will not receive any messages that have already been processed or have already been sent and consumed by other consumers. So that is something that in some cases is a negative. So if you want to do something that also needs to be able to process a bit of backlog, or where you need a little bit more context in order to process the messages, then there's a second way to do this, and it's called streaming. With streaming, the broker will actually receive all the messages, will have a buffer of keeping those messages, and then consumers can go in and either just take the latest message that just arrived, or they can actually read in that backlog that the broker maintains to then process messages that have been sent like maybe half an hour ago. So these buffers are typically not that huge, but they can be very, very useful if you want to process messages later on. Now, what all of this gives you is this decoupling I was talking about. So the mouse doesn't have to know anything about the application doesn't have to know anything about the mouse. And that gives you two very important things that you basically checkboxes that you always want to check off in your architecture that you have. One is called separation of concerns, and the other one is encapsulation. So a bit about tooling. Which brokers are available to help you with this architecture? There are lots and lots of different brokers. I just put a few up here on the slides. The most important one is Apache Kafka. It's also very, very scalable. It's written in Java. It's not written in Python, but that shouldn't bother you. You can just communicate very easily with Kafka using Python interfaces. There are a few others as well. Apache Pulsar, for example, is a new project that aims to be more efficient than Kafka and eventually then tries to replace Kafka. Also provides some very interesting features with respect to the queue that you have in streaming, because you can actually go into the queue and then run queries on this queue and then get a subset of the messages that you're interested in. There are a few others, like Postgres, for example. How many of you know that Postgres has a pub/sub mechanism? Oh, excellent. Actually, quite a few. That's surprising, because at the last conference I was at, no one knew about this. So this is interesting. For smaller projects, basically, Postgres is the go-to thing that you need for your project, right? Because it provides you with a relational database that's very, very capable and very stable and very easy to set up and maintain. And at the same time, it has all these extra nice features that you can use, including the broker support. And of course, the standard one that web applications often use is Redis, right? There are a few other areas where you might want to use a broker. If you're in finance, then AMQP is a very, very popular protocol, and you have RabbitMQ for that. If you're doing IoT, so Internet of Things, small devices communicating with each other, like sensors or maybe your heater, then you can use MQTT, which is a very, very small protocol, very tiny thing to implement that works very well on small devices. And there are quite a few implementations there. A very popular one is Mosquito for smaller things that you do, or maybe to try out things. And then if you really want to scale up, you should go to one of the big ones, like Apache ActiveMQ or HiveMQ. And then if you're in a cloud, then of course all the cloud providers provide their own solution, right? So I only put up a few here. You can just have a look around. The problem with these often is that you have lock-in, right? So if you set up one of these other ones and run those in the cloud, you're usually better off with that, unless you want to have something that's managed. I also want to mention something, very old kind of system, which is called IBM MQ series. How many of you know that one? Oh, yeah. Interesting. So that was used in banking like 20 years ago. I think some banks still use it. In those years, pretty much all the transactions in banks touched MQ series in one way or another. It was like the message bus that you used at the time. Right, so what do these brokers have to solve and do solve for you? Actually, quite a few things. So one thing that's very, very hard to do correctly is processing messages only once. It may seem like a very simple thing to do, but if you actually go and implement this, then you find that there are so many corner cases that you have to be aware of, so many network issues that can go wrong, that this is actually quite hard to implement. Another one is guaranteed delivery of messages, because, for example, let's say you're doing a financial operation, then you want to make sure that when you debit one account, that the debited amount actually goes to some other account as a credit, right? You don't want to be lost in transit. Or the other way around, if you're, let's say, you're a vendor, then you want to get your money at some point, right? Not just give out the goods for free. So these two things are very important, and the brokers, they basically all solve this. In some cases, like MQTT, you can also switch this off. You can also go to a certain lower level. For example, if you're not interested in all the different sensor readings, and it doesn't really matter whether you get all the temperatures for all the different intervals, then you can just switch this off, and then it makes it more efficient. One thing to be very aware of is failure modes in your architecture. So if something goes wrong, you have to have your systems be capable of recovering from these things. So messages might get lost, for example, in this IoT case, and your components need to be able to handle a situation. So basically, you have to work with the NA values in your data. Whoops. Okay. Oh, I'm very sorry. Windows just decided that it has to run an update. Okay. What are we going to do about this? That is not a good thing to happen in a live talk. So, I'm going to use my phone, and then unfortunately you cannot read the slides, but at least I can continue talking. Right. So I talked about the brokers that you can use, and I talked about the challenges that brokers have to solve. So there's lots of tooling out there. You can use lots of tooling for implementing your architecture, and you just have to worry about the interfacing with the broker that you do. Now, the next thing that's very important in these architectures is that you communicate how the different producers and consumers communicate with each other. So to let the consumers, for example, know what kinds of messages they should be expecting, and to also give the producers a chance to basically announce what kinds of messages they will be sending. So you need some kind of API specification. Now, you know from REST, for example, you have Open API or Swagger. GraphQL has its own spec. So you can very easily tap into, or get to know what kinds of data that they will be sending or receiving. With EDA, it's a bit different because everything is async, and versus the synchronous kind of approach that you have in REST and GraphQL. You have to do it a little differently. So the wording, the terms are a bit different. They're more geared up to pub/sub kind of interfaces, to async interfaces. And so what you have there is something called Async API. Async API was started in 2017, and it's also an API specification that's very close to the Open API specification. Essentially, what they did is they just used the different things that you have in Open API, the synchronous things, and then replaced them with the corresponding terms and tokens and features from the async space. So you can read up on that on the internet if you search for Async API. What's unfortunately the case, though, with Async API is that Python is not very prominent in Async API yet. So the Async API community is very much Java and Node.js focused. So there isn't a lot of space there for Python. And this is also one of the reasons I'm doing these talks at conferences, because I would really like to have Python a more prominent kind of approach in there. So if you feel like you want to, help with this, then it would be nice if you could, step in and then maybe help out with that. So it's really unfortunate I cannot show the slides. Right. So there's a quick recap of what event-driven architectures are. So essentially what you do is you pass around messages, you have producers and consumers. Everything is decoupled. You write your application in components, and the components are isolated and encapsulated. So you can change components individually. And this is one of the nice things about the async. Is that a different laptop with a presentation on, or? No presentation. Okay, so I don't have much time left, so I'm just going to continue like this. So it pretty much is like the ideal thing that you would want in an architecture. Of course, there are also some issues with this, right? Because you cannot have something that's all the way nice. There are always some challenges around these things. So one big challenge is debugging these architectures, because as you can imagine, if lots and lots of things happen, lots of messages that get sent around, lots of components operate on these messages at different times, it's very, very hard to figure out what happened at what point in time. And so this is where observability comes in. So you have to build observability into your architecture right from the start. If you don't do that, it's going to be a nightmare when you want to debug something. And a very good hint in doing that is do add IDs to all the things that are happening in your system. Add IDs to the components that you're using, add IDs to the requests that are coming in, add IDs to all the events that you have, and maybe even add IDs to the topics, so that you can then collect all the log messages and then have a query engine run on that. For example, if you're using AWS, you probably know CloudWatch. In CloudWatch, you can very easily group messages by these IDs once you have this. And especially in Python, if you're logging something, you use struct log, for example, to have structured logging in JSON form. You can feed that directly to one of these log engines, and you can then do the queries on that. The other challenge is an organizational one, because you will have lots of different departments working on the parts of the architecture. And so in order for all of them to know about what you're doing there in the architecture, you have to have good documentation. And this async API documentation is actually a very good way to do this and solve this. So just a few words about IDA and Python. Unfortunately, there isn't all that much. I would have some slides here to show you which packages are available. There is one package called async API, obviously, but it's kind of dormant. It hasn't been updated for a longer while. There are a few others that are coming and trying to help with this. So, for example, ones that for Fast API or for Flask, they try to expose the async API spec based on what you've implemented. But there isn't really a lot available. And this is, again, a call out to people who might want to volunteer to help with this and implement something in that area, because it's definitely something that's very big and that's going to be very big in the future. Right now, you have smaller companies, well, no, not smaller companies. You have very large companies using this. For example, Amazon switched from a monolith application that they had to this IDA architecture in order for them to actually be able to handle this kind of load that they have. And if you want to be in that space, then you can do that as well. But it also works for smaller things, right? So if you're just using something for IoT, for example, you have a Mosquito server, it's excellent. It's an excellent tool to use. There are also lots and lots of ways of interfacing with these brokers. So if you have chosen a broker, there will most likely be an interface for that broker. And so it's very, very much possible nowadays, even though there aren't specific packages for the async API or for IDA in Python or in PyPI or on PyPI, that you can still interface to all these brokers and do your thing. And then this is what companies are currently doing. So in conclusion, roll your own, meaning that you take the broker and then use these interface libraries that you have on PyPI is well possible. We do need more support in Python, and the community should really step up there and do something about it so that we no longer have the Java and Node.js dominance in that space. And yeah, that's basically all I wanted to say. And main takeaway from the talk is, always try out new things, never stop to learn, even if they're more than 20 years old. Thank you.
Thanks. So I'm going to preempt with a question. How might we be able to see the slides? Can you think of a way after the fact?
I can upload them somewhere. I only don't know how to communicate the upload location to everyone here. Maybe we can do something. I don't know.
All right. We will figure out a way to do that. But we are going to, we don't really have time for any more questions.
Oh,
so
I know one way. I can upload them to LinkedIn, and then you maybe follow me on LinkedIn, and then you'll receive the link, and you can get the slides from there.
Excellent, excellent. Thank you. Another warm round of applause for our co-organizer. Thank you.